Hello there, and this is another project I'm making now. It's actually, funny enough, derived from yet another project. That seems to happen quite a lot. I mean, you begin something and then you realize you need something to test a component or some kind of support or enclosure or whatever, and you end up doing something for something else. In this case, this winter we had a really bad episode of freezing rain. There was a lot of ice on cables, on trees, on absolutely everything around, and that caused massive disruptions with the electricity. To hell, these neighbors. Swear to God, sometimes you think the neighbors will crash down through the ceiling. Caused major disruptions with power distribution, like electricity turning on and off and on and off again multiple times, even a few times a second. And one night I just went to sleep, and the next day my brand new computer was dead. Luckily it was just a power supply, but then I knew I had to do something because I didn't want to risk anything more than that. Plus, if the manufacturer can see or is really unwilling to help you, they can invoke it's been due to power network fluctuations, and that, at least here in my country, isn't covered by warranty in any way. So that's a pretty major risk, so I decided I have to put everything I have on an UPS. I had an UPS lying around, which you can see here through all this mess. There it is. It misses the decorative front cover, but that's not an issue. Now the problem with that is that it has a fan that it's constantly turned on, and I tried to see if there's anything that requires actual cooling, because you can feel by hand, if it's something that needs to be cooled. If you take away the fan, it will go pretty hot pretty fast. Usually you can't even touch it, but in this case everything was just ice cold, even under load. So, well, not ice cold, but well below any kind of dangerous temperature. So I wanted to just pull the fan out, see how that goes, and the damn thing just wouldn't accept that. It has a really good protection. You can't slow it down. You can't remove it because it goes into protection mode and doesn't start up again until there's a fan running and it has the correct RPM. So of course I could do some research and see what kind of waveform there is on that RPM detection wire, and do a circuit that would, an oscillator of some kind, to simulate that. But it's just, there's no point in doing that. I just moved the UPS on the balcony here together with the PC, as you saw earlier, and that way I got rid of the noise too. It's not the first time I've done this to whoever is concerned about condensation and temperatures, and they don't care. PCs don't care. You can keep them at -10, at -20. There's no condensation. And keep in mind, I've had a lot of people saying this and pretty sure of themselves, but this is really like primary school physics, even homeschooling before kindergarten, because parents should tell you this before you get to school, that condensation only appears on cold surfaces in hot environments, not the other way around. So as long as you have a device, an electronic device that will heat up like a PC and put it in a cold environment, nothing is going to happen ever to it. So there's no condensation, nothing whatsoever. More than that, I've had windows open, rain, snow coming in. Nothing happens because you have the case. It might get a little bit wet, you know, a few drops here and there, but that's really not an issue. You know, if there's, I mean, you can't keep it like 10 inches away from the window, but if it's pretty far away, like it is here, you know, I think that's what's that like in retarded units, 3 feet from the window. So there's the PC on the far right there, and there's the window, so you have this distance that's more than enough to protect it from, and it's under the shelf anyway, so it really doesn't care. Put all the wires in a nice wall electric tubing like this. It's just all fine. It works just fine no matter what temperatures you have. So even with it on balcony, there's still an issue because I don't like that fan, you know, running continuously, because at some point it will fail if it just runs 24 hours 7 days a week. So I have made a mains switch here on my desk that I press to bring mains voltage to the UPS, and every morning I have to press that switch and then come over here and power up the UPS. Then I've set the PC to auto power on power failure, and that's just you know, it's not very practical, and every time I shut down the computer I have to come here, turn off the UPS, and then go and switch off the mains voltage from the desk. So I figured I could use one of these very nice 555 ICs to make a timer that can do that automatically for me. You know, like having a pulse that goes automatically when power is applied, you know, for like a second or two, or how long it takes to power up the UPS, then go low, and then have something to detect to go off when I turn off the PC, and then have another pulse that will shut down the UPS. Basically, I think through the same oscillator I could do that, because it needs the same length of a pulse, I think. I'm not sure, you know, and that's what I said with designing something else. I never quite got to the part where I designed the circuit for that, because I had a bunch of 555s laying around, and I knew for sure that some of them are really gone, burnt, dead, gone, and then I decided to build a 555 tester to see if they're good or not. So that's what this is. Really turns out really well. I'll have a lot of content for this channel. It's really simple. Let's see if I don't have the schematic anymore, or do I? It's pretty much this one. Very simple indeed, just a few connected pins, a couple of resistors and capacitors, and that's it. Plus the LEDs and the resistors for those. And it just, at first I did it on this test board here, but then I thought I would do some kind of casing for it. I don't have any professional looking casing. I have this cap from a large plastic jar, and I think this should do just fine. You know, I don't really like to spend my money on things like that, just to, as long as it looks pretty decent, I think it's okay. You know, there's no markings, no scratches, it's all in one piece. it should be just pretty nice. And also, as a side note, because this is quite some short information and it wouldn't make sense for a separate video, I had on this cap one of those printed QR codes, you know, like ink printed, so you can scan it with in the warehouse or whatever that is for. And what I found out, you know, there's a lot of cases where you need a label or some kind of imprinting to go away from something, you know, I mean, cleaning, you know, that residue, that glue that stays behind the label. God, those are so annoying. I mean, you can use soap and detergent and hot water and vinegar and whatever you can think of, and that will still stick, you know. And there are some solutions that claim to do that well, but what I found out, I had this WD-40, but be careful, it's not the actual WD-40, it's the Specialist Edition Fast Release Penetrant. So it's used, I'm not even sure if it's the classic WD-40, it sounds like it's doing the same, but from the same series I've also had a contact cleaner, so I'm not very sure about that. Anyway, it's the lubricant kind of thing, and this thing will remove labels and printed stuff from surfaces in an instant. I mean, it takes only a few swipes with a paper towel and it's gone. It's completely gone. It was right here in the middle. I don't think you can see anything right now. There's nothing there. This thing is brilliant for getting off any kind of label, printed stuff on packaging surfaces. Really nice. You see, like this Intel thing right here, if you use this, it'll come right off. It's a matter of seconds. So what I want to do now is put a few holes in this, maybe align it like this so it will, these connectors would come through the top, and then I grab myself a couple of LEDs here and put them maybe on these two smaller leaves here, you know, like that. And there's a button. I don't know where I put the button, but I'll see. Okay, so I've already marked this plastic. You can see there are a couple of screws here. Whoops. At least that didn't go on the screen. And now I just guess I'll have to drill a couple of holes. Also, where I'm from, there's none of that health and safety crap, so I'm going to drill this in hand. So if you have anything against that, too bad. We're not a bunch of individuals living in plastic bubbles here. See, I'm still alive. There you go. That's pretty damn nice. Why do I keep dropping stuff? Well, that's me. You'll get to know enough of me. That will be insanely nice. Okay, now just put it back. Unfortunately, I don't have any kind of labeling. Oh, and yeah, there's two things I need to do before I actually go ahead and leave the circuit board there, I need to... Well, can I do a bit more zoom? I need to put this capacitor on the side because it's too tall for the enclosure, and I need to get rid of the IC connector here and somehow, I think, drill a bunch of holes through the plastic and just glue it on top, and then go with wires from behind to the board. So that is something I will have to do. I'm not sure about the button. I could use a plastic part that goes through the enclosure and inside the circuit. Yeah, that would be a nice approach. But I need to do this first. So first the green capacitor. Now for the other one, I think I'll need a couple of leads, which I might take from this LED. Oh, and by the way, if you decide to build your own 555 circuit and for some reason it just doesn't appear to oscillate, or doesn't oscillate in the way that it's supposed to, and you're sure the 555 IC is good, then I recommend taking a look at any electrolytic capacitor you have, because I used an old one. You know, I don't think I have many new components. Like 95% of them are salvaged from older electronics, and apparently that one was gone. Though physically it looks okay, you know, it can be dried out, and I'll just hold it with my finger. That appears to be the only method that actually works. Till you feel that sweet burnt meat smell. Pass by so you can see. Okay, so I'm back with working on this 555 tester. Taking a look at this, I want to put one of these buttons recovered from an old telephone and somehow drill a hole where the micro switch is. I don't know if that can be seen on camera. Yeah, it's pretty good actually. This is where the switch is. I left a mark earlier today. I don't know if I got the right spot, but I'm gonna check that out now. Looks pretty decent, I guess. I didn't want that to happen, but okay. Also, does anyone know how to get rid of that extra plastic that forms when you drill? Because I have no idea. I just have to use a blade to get rid of it every single time. And it's on both sides too, so it's not like you go with the drill from one side or the other. And that will make it look like crap. Maybe a bit of sanding if the hole is smaller. Let's see if I got the position right. So this will be good enough. Don't know what to use there, maybe a thin piece of sandpaper. And that looks right. Okay, that will work. Next is the actual chip holder. Oh boy, this is gonna ruin some traces because it's all made with solder. I wonder, could I just use the solder pump? Hey, what if I just... There's a brilliant idea I have that requires an extra connector, and I'm not sure I have one. Yeah, I have an extra connector. More than one, actually. Okay, so let's put those back. I'll try to mark it somehow. How can I do this? It's really, you can't see much from... No, I'm gonna try marking it with a marker. Yep, that works. And just putting it against the light, and I don't know if I can show you. See? That's from the light from behind. This is the front, and this is with the light from behind. The thing is, I don't want to punch like a square hole to put this connector. I only want to put the pins through. That will make it look really nice. And let's see if I can maybe scratch an outline of the pins. Wow, look at that. Look at that. And let's see how this works. Oh, one of them broke. What was that? Looks promising. I would have liked another screw or something on this side, but it's really tough to do that without ruining the whole thing. They're too long. The button falls out. And another one broke. Come on, come on. I'll just screw it in and give it a test. And see if it works. Moment of truth. I'm gonna find a way to mark the polarity too. That would be the minus. Oh, I don't have the LEDs. Yeah, that's pretty nice. I think I'll put them somewhere in here. On each end of these two leafy kind of things. And would you look at this? Just look at this. Doesn't that look great? Sure does to me. Wires. Wires! And let's go. Let's put some solder on the LEDs. And the usual redis plus. Black is minus. And okay. That being a plus, it should be
plus. Oh wait, no. That would fry my LED because I put it directly to the plus rail instead of passing it through the resistor. Minus, then a plus on the 555 output, and a minus on another resistor. And that should give us a light show. Shall we? Let's check the polarity again. Okay, moment of truth. Maybe put the light away a bit. And that, my friends, is a 555 chip tester. Take a closer look. Push the button. And it goes blink. Let's pull the IC out. See if it does anything without it. Oh, it actually turns both the LEDs on. Got bent a bit. It's got solder on its pins too. And it's back on, back blinking. That, my friends, is a 555 IC tester. Thanks for watching. See you next time with the next project.